but if you want to get ready for it, there's a slew of problems on Delta Math already posted if you want to get going on it. And this is not a scare tactic. I want to warn you way ahead of time. This is going to be a tough one. All right, I'm ending the year on a tough one. All right, it's basic. I think it's like 6 or 7 word problems. I'm not doing this. Hi, I'm a cone. I have a radius of 4 and a height of 6. Find my volume. No, sorry. Not going to do that. All right, that's a waste of time in an honors class. So about 6, I think there's 2 density problems, similar to what we're doing today and yesterday. And then anybody remember in notes a couple days ago, you had the cone and you had the cylinder. How many cones could I fill up with water? So it filled up the cylinder, things like that. Okay, so that's what I'm going to be going for. All right, I am going to skip all the way down to problem number, it's the boxing one, 5. Our guy of the year, Big Al. He'll make another appearance on your quiz on Tuesday. And then last day of class is the big reveal. Who is Big Al? Who is Big Al? All right, go ahead and read through it. There's a lot to this problem. Let's start talking. Here's the question. I'm going to put sand in the base. How much does this whole thing weigh? All right. If I summed up all the words up here, how much does this apparatus weigh here when I fill the base with some sand? Well, it doesn't have sand in it right now. How much does it weigh right now without the sand? 13?
95.4%.
That's how much the sand weighs. How much does this whole thing weigh without anything in it? 270 pounds. Everyone agree? This bad boy's 270 pounds. So here's your answer. I don't know when it's going to come up. I'll put it way down here. Here's my answer to this problem. 270 plus, what do we need to find out right now? Weight of the sand we're going to put in, right? So there's our final answer all the way whenever we get to it. It's going to be 270 pounds plus the weight of the sand. So that's our job. Find the weight of the sand, which is what variable in D equals M over V? M. We're solving for M here. Okay, we're solving for M. So speaking of D equals M over V, do I know the density? Does the problem give me the density? Because I don't see the word density, but I see units attached to a number that says, hi, I'm the density. Which one represents the density up here? 21? And why? Look at the darn units next to it. Pound, mass, per cubic foot, volume. That's how I know density. Mass and volume together. 94.46 equals mass over, you ready to find the volume? Because that's always what you guys have to do, right? Always find the volume. Volume formula for a cylinder. Look back if you need to. It's right on your formula sheet. 21 again. Ella? Good job. Pi r squared h. This is where you have to break through being an average student to an honors student. Read the density again for me. 11. Easy job for you. Read the density for me. Slow it down. Pounds.
of pounds per cubic foot.
What was that last word you said, Paul?
Foot.
One more time.
Foot.
What's our diagram in? It ain't gonna happen. You're not finding the volume yet. Your density, the density has to match the object's measurements. And you got to do it now. You cannot wait to the end of the problem and divide by 12 because that's not the conversion. I tried proving that to you guys yesterday. Your density needs to match the object's measurements, which it doesn't. So I need your help right now turning 20 inches and 18 inches into feet. Then you can find the volume. Everyone understand that? Density needs to match the object's measurements. 20 inches into feet, 18 inches into feet. What's up, Mahmood?
Can you find the volume then divide by 12 or not?
No, you cannot, because here, watch, here's why. Here's why. I'm trying to do my best to explain this to you guys. 1 foot, here's the conversion. 1 foot equals 12 inches, right? But the volume's going to be cubed. So 1 cubic foot does not equal 12 cubic inches. Now, if you want, and you can handle it, divide by 12 cubed at the end, sure. But not 12, 12 cubed. All right? So that's why I always suggest just do it now. Don't even worry about all that stuff at the end. 18 inches, what is it in feet? 7, 18 inches in feet? 1.5. 20 inches in feet. I don't want the decimal. Leave it as a fraction, please. Leave it as a fraction. I don't want the decimal. 4? 1 and 2. Can I put 5/3, Griff? Is that all right? All right, I don't want to offend you. But yes, you were right. 5/3 of a foot. All right, now it's in feet. Let's calculate the volume. Pi. Huh. You thought this was you're on easy street now. What's the 5/3? That's not radius. What is it? 4. Griff, what's the 5/3? That's the diameter. I need the radius. So everyone go to your calculator. No big deal. 5/3 divided by 2. There's your radius, 5/6. There's your radius. 5/6 squared. And what's the height of our cylinder here? 24? 1.5. There it is. Here's our volume. Not even going to ask anymore. Write it all out. Now that's in cubic feet, just like my density is. You want to plug it in now? Plug it in now. Okay, go ahead. That's fine. Ready? Let's go back up to the old dense formula. What units is my mass going to be in? What units is my mass going to be in when I solve for this? 20? What units? Pounds. Why? That's what the density is in. Remember that. The density will tell you what each one's going to be. So my answer is going to be in pounds. I didn't do it this way, so I guess I got to do this. $312 and change. How's that looking? Add it to 270 and I'm done, because that's how much the sand weighs. Add it to 270 and I'm done. No. What does that number represent? 312. Go ahead, Lauren. What's that number represent?
100% of the base.
The entire base filled with sand. That's how much it weighs. 312, the entire base filled with sand. I'm not filling it the entire thing, am I? How much of this base am I filling up? 2. Go through the whole problem there, Matt, at the end. How much of the base am I filling up? 85% of it. So I need to take 85% of this 312 here. Also, I don't know, was anybody thinking taking 85% of the volume down here and doing it into density? That would have been fine too. Okay, you could have taken 85% of this before plugging it in. Either way, it doesn't matter when you do it. That number right now will add to 270. And when you're ready, it says to the nearest pound, right? Yep, to the nearest pound. How much does this apparatus weigh with the sand in it? 16 when you're ready. Yep. Not bad news, but maybe scary news about this problem. Jonathan? Darn right it was. It's from a previous Regents exam. That problem right there we just did. All right, so if anybody is in the mindset of, oh, I'm honors, and other kids will be taking this that are lower geometry than I am, take a look back at that problem and remind yourself it's not going to be any joke. Okay, because yes, that came from a previous Regents exam. All right, you guys are done. Open up your Chromebooks. I want my answer key on everybody's Chromebooks as you start doing these problems. If you get stuck, because I showed 0 work. All I showed was answers. So if you're struggling to get to that answer, let me know. Watch for change in units. Watch for change in units. Make sure your density matches the object's measurements. If you want to move around and work with other people, I'm fine with that too, but it better be on density. I had to make a new one up earlier, so I want to make sure I actually have the correct one here. Yep. Okay, we're good. Again, take a quick peek. If they give you density, please make sure it matches your object's measurements. You're in the same unit. If not, convert it now.